A mid-latitude cyclone. Let's look at this definition. A mid-latitude cyclone is defined as intense low pressure storms system that develop along the polar front, and it influences the weather at mid-latitude at 30 degrees north and south and 60 degrees north-south. So it is easy to understand this definition. First thing first, we need to understand what is intense low pressure, or what do they mean when they refer to intense low pressure system or intense low pressure storm. It simply means that it's a strong low pressure system. All right, what is low pressure? If we have to understand this definition further, low pressure, it's the pressure exerted on Earth's surface. If we can look at this, pressure exerted on Earth's surface, or the pressure it's exerted on Earth's surface. Pressure exerted on Earth's surface. Okay, so this pressure is exerted by the column of air, right? That's where you will have high pressure and low pressure. So when we talk about low pressure, it means that there's a less pressure on Earth's surface, and that can happen when air rises. It can happen when air rises. It means that the pressure which was on the Earth's surface has been lifted up. Okay, and what is it that causes this air to rise? This air will rise because it's warm. We know that warm air is less dense. Warm air is less dense. Okay, what does that mean? It means that also means that it's light, which means that will be easy to be lifted up. Okay, but you need also to understand high pressure. If you want to understand more about low pressure, you need to know the difference, and the difference between high pressure and low pressure is that high pressure, the air is sinking down. The air is sinking or descending or subsiding. Okay, which means that and this air that sinks is cold. The air mass, when we talk about warm and cold, we're talking about the air mass. Okay, the air mass that sinks, it's cold air. Okay, which means that it's heavy or more dense or dense. I may not say more dense, just say dense. Okay, it's heavy, therefore it will be forced to sink. Okay, and form what? And form high pressure on the Earth's surface. Whereas warm air rises to form what? To form low pressure on Earth's surface. Okay, so on your synoptic weather map, you will find isobars. Okay, isobars, right? You will check for me what isobars are. You will check for me what are the isobars, or how isobars look like on a synoptic weather map. However, is the lines drawn on a map joining equal pressure. Okay, So let's say here you've got an area of low pressure, and here you've got area of high pressure. Okay, and remember, all this attempt that we are trying to do here, we're trying to understand the term mid-latitude cyclone. Okay, we're trying to understand the term mid-latitude cyclone. So these isobars have isobaric value. Okay, isobaric value, let me say 1000. You have another isobar, okay, surrounding this low pressure. Therefore it will be 1004. Okay, then you have another one. As you can see, they are increasing towards the area of high pressure. Therefore here it will be 1008. Okay, they will also increase. Okay, it will be 1012. Okay, so as you can see, the distance or the interval between one isobar and the other, it's 4 HPa, 4 hectopascal, right? 4 hectopascal. Okay, and as you can see, we are moving towards the area of high pressure because your numbers are increasing. Okay, the number from 1000 to 1012 are increasing. However, from 1012 to 1000, the numbers are decreasing, which means that the pressure is being reduced. Okay, the pressure is being reduced. And here around this area, we can say, if you've got another isobars here, we can say it's 996. Okay, because remember the interval is 4 hectopascal. So 996, it means that the pressure has been reduced. Okay, and the reduction of pressure, anything, the pressure which is less than 1000. Okay, here you will refer to 996. Okay, hectopascal. We can say 998 hectopascal. Okay, so we are referring to intense low pressure. When we talk about this, we're talking about intense low pressure. Intense low pressure. Okay, as I have indicated before, or in this slide, I said that low pressure will be formed by rising of warm air, right? So if you've got a quick rising of warm air, your pressure will be reduced. Your pressure will be reduced to less than 1000, and in that case you have intense low pressure, right? So let's go back to our definition, because all this attempt to remember is for understanding what mid-latitude cyclone is. We said before, it's a strong low pressure storm system that develops along the polar front, and it influences the weather in the mid latitude. Okay, mid latitude, we're just referring to in the middle of lines of latitude. Okay, so I will explain that later, maybe in the next video. All right, but we said this pressure develops along polar front. Okay, this pressure develop along polar front. So let me try to show you what does that mean. Remember, we've got our globe, and in this globe we've got lines of latitude, as I was referring to them, and the famous line, it's equator at 0 degrees. We've got subtropical at 30. We've got another line, subtropical at 30. We've got polar, subpolar at 60, and we've got subpolar at 60, and we've got polar at 90. Polar at 90. So you remember in grade 11 you have learned all these pressure belts, okay, which I will also explain them in detail. However, in this video I just wanted to show you, or I just want to show you this polar front. Okay, so remember, here is equatorial low pressure, here it's subtropical high pressure, here you've got subtropical high pressure, and here you've got subpolar low pressure and subpolar low pressure. Here you've got polar high pressure and polar high pressure at 90. Okay, so the area I am referring to is this area, which I will explain later in the next video. And remember, I said we said it influences the weather at 30 degrees north south and 30 degrees 30 degrees north south. Okay, so polar front is this line here. But let me explain something. What is a front? Let me explain what is a front. A front, it's a boundary. Okay, you can write that down. Front, it's a boundary between two air masses. Okay, or boundary that separates two air masses. Okay, which will be warm and cold, right? So if you've got warm air and cold air, the boundary here between this air is called front. Okay, and the name of this front will take the name of the air that is behind. Okay, let's check here. The air that is behind is warm, therefore this front is called warm front. Okay, then you will see it by some humps. Okay, then if you've got cold here and warm, these air masses, okay, we check again the air that is behind. Okay, the air that is behind is cold, therefore this front will be called cold front, and you will see by sharp spikes. Okay, and then as I said, the front is a boundary between cold and warm air. Okay, so here we've got a warm air coming from the west region, or warm westerly air, And then here we've got cold air coming from polar regions, polar easterlies, and it's very cold. So this air will meet with the air that is coming from this region. So warm will meet cold, therefore you have a front. Okay, and this front now will take the name of where it is found, which is at the polar region. Therefore it's called what? Polar front. It's called polar front. Okay, let's try again to understand our definition. Okay, we said is the intense low pressure system that develops along the polar front, and it influences the weather at 30 degrees and 60 degrees north south. Okay, so now we understand that this system is a system of intense, strong, low pressure. Okay, how do we know that low pressure is strong? Okay, we know that low pressure is strong when the pressure is less than 1000 hectopascal. Okay, so we go to our synoptic weather map and check the pressure there. All right, and then if we find that the pressure is less than 1000, we know that there is rapid rising of warm air. Okay, there is quick rising of warm air, or rapid rising of warm air, right? Of warm air. Therefore our pressure will decrease, okay, to less than 1000. Okay, I'm just giving an example here that 996 hectopascal, 998 hectopascal, right? So the pressure will decrease, right? So when you see this smaller number, right, of 996, any number that is less than 1000, okay, and I'm giving you this number so because we can't have a pressure low pressure at 20. No, we will I'm giving this number because those are real numbers. Okay, so when you have those numbers, just know that the pressure is intense, the pressure is strong, right? So if someone asks you what is making this pressure to be strong, right? Simple answer: the pressure is becoming strong because of quick rising of warm air, or rapid rising of warm air. Your pressure will be intensified. Okay, so this thing is forming, right? Where is it forming? This pressure is forming along the polar front. Okay, therefore you have your mid-latitude cyclone. Okay, the quality of video, I don't know about that, but I think I've tried. It's my first attempt, but I think we're gonna have a lot of videos on this subject, geography, and then I hope you will understand and enjoy.